thank you all for joining, both in the room and on the live stream. I'm Janet Matsuda. I'm the Chief Marketing Officer for Nimble Storage. And today, Nick Dyer and Rich Fenton are going to be talking about a couple topics. One of them is how we are focused more now on making it about apps rather than just about infrastructure. So as we know, sometimes there can be a little bit of confusion when you've got an apps team and they're asking for capacity and performance, and you have a storage team, and they're not always speaking the same language. So one of the things that we are focused on, both with the product that we announced recently and as we go forward, is how can we make it easier for them to talk the same language and in fact provide tools where the person who's managing the apps can actually be more independent and be able to manage the storage themselves as well as work with their infrastructure team. So with that, I'm going to turn it over to Rich, and he's going to get started.
Good afternoon, everybody. My name's Rich Fenton. I look after the systems engineering team in the UK at Nimble Storage. I've been at Nimble for close to 4 years now. And what I'm going to do is just give you an overview of what we're going to talk about today, specifically around reducing the application data gap and how Nimble Storage helps our customers reduce their business risk and allow them to provision storage to applications much more effectively. I promise this is the only marketing slide that I'll have today. By all means, please ask questions. We're more than happy to go and technically deep dive into some of the stuff we're going to talk about today. But I just wanted to let the listeners and yourselves aware of where Nimble Storage have come from. So we were started in 2008, and we were founded by two industry veterans with a real track record of bringing innovation to storage solutions to market. Our product came to market in 2010, and since that time we've seen a huge amount of accelerated growth. So at Nimble, we really count growth around a few metrics. The first metric is around how many customers we've adopted. So since 2010, we now have over 9,000 customers that are running active workloads on their applications on Nimble Storage. And that growth really fueled our capability to be able to provide not only applications to our customers, but also to get us onto the Gartner leader in the Magic Quadrant. And we've been there for the last 3-4 years. And it also fueled our IPO. So we IPO'd in December 2013, almost 3 years in mid-December. The other thing to notice is that customers really like consuming our product because it's exceedingly easy to consume. Very different from exceedingly easy to use, which is a pretty GUI. So our Net Promoter Score is over 85, something that we're very, very happy about because our customers, when they interact with us and our support, which is some of the stuff I'm going to talk about later on, they find it a very innovative solution. We're a storage provider, and often customers are providing and provisioning for solutions. So we provide storage to the hypervisor and to the application, something that Nick's going to talk a lot more detail about. So we spend a lot of time with technology alliances to integrate our solution to the wider ecosystem. So whether that be converged systems, whether it be backup or replication, data protection, or whether it be specific solutions like the hypervisors or the applications, we have to make sure that they can interact with the storage layer on the most effective manner. So we have a huge amount of technology alliances, co-development, so that our solutions work really well. And there's two recently that's been in the press a lot. Our Veeam integration. Veeam is a fantastic data protection capability, and Veeam has the capability as of 9.5 to be able to integrate, to be able to leverage our snapshots for instant backup, and more importantly, to use our restore capabilities to make customers' applications restore quicker. And just yesterday, we announced our Lenovo relationship, which is really around converged offerings with Lenovo as a compute platform. So I was going to leave it there from a marketing perspective. And really I was going to focus on what do our customers expect. And as consumers of technology, whether we're working in the data center or whether we're actually just using our devices on a daily basis, we expect data to be instantly available. And we get incredibly frustrated if it's not available for whatever reason. Because if it's on my map, I'm trying to find the destination to this hotel, or if I'm using the application to do my day job, if I get one of these signs, I can't do my day job. And sometimes it means a loss of productivity, some interesting studies on how much that equates to. But more often than not, it may even lose revenue. So a great example is my wife was placing our holiday for our summer vacation. She went to our website, she got one of these signs, and she went straight to a different website and placed our business with somebody else. And the cause of those slides is usually because of the disparity between what the applications require, what the consumer requires, and what the infrastructure is capable of delivering. And there's multiple ways to solve that. We defined this as being the application data gap. So the gap between the requirements being met and the capabilities of the infrastructure providing those applications. So there's a couple of ways to solve this problem. Firstly, we can just throw hardware at the issue. Bigger CPUs, faster CPUs, more memory, faster storage. Instead of using nearline SAS drives, I'll use 10K spindles or 15K spindles and use lots of them, or I'll move to all flash. And that's really where our platform, our heritage came to market. We have an adaptive hybrid array that uses nearline SAS storage, traditional capacity, high capacity, not something that you equate to high performance. And we fuse that with 3D NAND SSD drives. And we converge these into a hybrid platform, which gives our customers and our users very, very low latency, very, very high IOPS that scale independent from capacity and performance. But of course, there's a shift in the market. Some people believe that a disk drive can't perform. No matter how well I can talk about our architecture and how we get this platform to perform, there are certain levels of customers and certain levels of apps that just don't want to see a disk drive at all in their solution. And that's why we came to market early at the beginning of this year with an all-flash array. So that uses the same software, it uses the same platform, but obviously it doesn't have a disk drive. It's just got SSD, 3D NAND SSDs in there. And this is a next generation system that's really a cut above of what the all-flash array market is capable of today with regards to data protection. Say again.
You said that you're using the same software to work with an all-flash array as with a hybrid array as you had before. So did you make any optimizations to make it work with the specifics of flash drives and flash memory?
So there are obviously two different mediums, and to treat flash like disk is probably a falsehood. So when you think about flash, it fails differently. So there are some extensions. So for instance, the way that we run RAID protection, on our adaptive hybrid system, we run triple parity RAID. So we can have any 3 drives of the RAID group fail. On the all-flash array, we extend that to what we have, what we call triple parity plus, which effectively still uses triple parity RAID, but we have intra-drive parity as well that allows us to be able to fail, not just from a complete catastrophic device failure, but actually cell regions within the drive that may fail and recover from that. Another good example is that we run deduplication on the all-flash array because the cost per gigabyte from all flash compared to certainly a nearline SAS drive means that deduplication you definitely want to squeeze as much as you can from a cost benefit from the SSD drives. What's absolutely critical with both of these platforms is that we scale performance independently from capacity. So it doesn't matter how much media you have, whether that's all flash media or whether that's hybrid media, the performance comes from the CPU of the controllers. So we non-disruptively scale the performance just by changing the engines within the controller. And of course, if you need more capacity, then that's where we add the media in. And that's true for both platforms. So you can think of Nimble OS a little bit like iOS or Android. These are engines. They have different performance capabilities. The all-flash array guarantees performance. But obviously, our services, our capability, our integration is part of our it's part of Nimble OS, and obviously that's where we'll spend a lot more time with the rest of the presentation. What's critical is that these form a unified flash fabric. So they can coexist. If a customer has different requirements, they can coexist as a logical controller, and we can provision to the appropriate type of storage, or we can interreplicate between two. I might have all flash in the primary data center, and I might not be able to justify that performance and that cost in the DR data center. So we can, combine them at the same site in a unified platform, really what looks like a single logical controller, or we can break them out between the two and have the appropriate performance in the appropriate location, depending on cost, but most importantly, depending on the business requirements. So we have a common data services framework. So as we add new features into our Nimble OS code, in the same way as Apple add new innovation into iOS, we get that across both platforms. So as we add new capabilities like quality of service, that becomes available with each of our platforms, and it also integrates into the wider ecosystem as well when it comes to solution integration as well. And then finally, something that I'll spend a bit more time on later is around InfoSight. So every time a customer deploys that array sends back telemetry information. And it sends back a huge amount of telemetry that we then use not only to explain and show our customers how they're using our product, but then also allows us to be able to be very predictive in stopping them from introducing problems and effectively reducing their risk. I'll spend a lot more time on that when we hand back over. So at that point, I'd like to pause and introduce Nick Dyer to you, and he'll go through the application-centric approach that we take when it comes to provisioning storage for applications.
So following on from what Rich was saying, actually, and following on to the question that was asked, the irony is actually that when Nimble was first being designed back in 2008, Nimble was actually an all-flash array company. It's not really known that well. There's a great blog by one of our venture capitalists, actually, on the day that we went IPO, about how we did a bet the company pivot into the hybrid model because we knew that that was a bigger market opportunity way back in like the late 2000s. So we've always had this file system been designed for all flash, right? That was the thing that we built and created and worked really well way back then. So we've had this file system, this uniqueness that allows us to do some really cool things. Now, the way that application guys think about it is not the same way that storage guys think about things, right? So storage guys, and I've been in storage and virtualization now for 13 years. Rich has been in storage and virtualization for probably a similar sort of time frame, and we've all done the same sort of work. Storage is all about RAID sets and LUNs and pools and aggregates and controller A and controller B and all the usual things that we think about as storage guys. Anyone that's not a storage guy does not think in that way, right? They think about applications, they think about what their requirements are around encryption, about data protection, about how to restore, and what actually the business services are for that application. So one of the key things that Nimble did way back in the day was actually to build an application-centric structure within the file system. Traditional storage arrays are built on a singular block size, right? So traditional storage arrays are built anywhere between a 4K block all the way up to a 15 meg block, which is what Equalogic was when I used to work there, way back in the day. Nimble is actually a variable block file system. So Nimble can actually read and write at multiple block sizes of 4, 8, 16, and 32K on the same RAID set, on the same pool of storage. Because of that, we don't want to expose that kind of intelligence to a customer. We want to expose an application side to the customer. Because application guys don't care about what a block size is. They just care about, hey, I want that to be optimized to SQL Server. So if you think about all the applications that customers run in a data center, virtual machines, VDI, UAT, test dev, SAP HANA, we're moving into the world of containers and Docker. All those different applications have completely different requirements. So they may have requirements around latency. Do I need a UAT and test dev box to get guaranteed sub-millisecond latency 100% of the time? Probably not. Probably need that for my production systems. However, I may want that on secondary storage where capacity is cheap. However, I may need to have requirements around security. So I may have a requirement where I'm an MSP, and I need to offer encryption to all of my customers because that's what I'm governed by whatever legal entity is governing me. Or I may have requirements about data protection, not just locally, but also remotely. I may be governed by a 7-year retention policy for certain financial services industries, for example. And also I need to be governed by scalability. So some applications are not going to scale, they're going to be quite stagnant. Some applications are going to go through the roof. So I need to be able to know how to control those. So with Nimble, we actually build application profiles within our array. So we're not building LUNs, we're not building RAID sets, we're building applications. And those applications conform to this essential requirement about how that application needs to be worked and used on the storage array itself. So here's an example of Oracle. With Oracle, I want guaranteed sub-millisecond latency. I want to have compression on it because you get really good data reduction with Oracle. However, Oracle databases and databases in general typically don't deduplicate that well. So I don't really want dedupe on my databases because I'm going to burn CPU overhead just to try and get some space savings. I want to have encryption at rest because that's what I'm governed by. And also I want to have local recovery for a certain amount of days. An example here is 5 minutes for 14 days. And also I want to have remote retention, which is something like Veeam or Commvault or even ArcServe. And that needs to be hourly and maybe retain it for 30 days. So what we do is we build this application profile. And that application profile is now consistent regardless of what type of media that we have, whether it's an all-flash array or a hybrid array. It doesn't matter to me because I build that application profile. So here's another example of that can then go on the all-flash. And with the hybrid, or a test dev system for SAP, for example, where it doesn't need to be hugely low latency. I can get away with it being quite high. I do want to deduplicate it, and I only want to take local snapshots but not replicate it. So I can create different entities within the system. And once I create these entities within the system, it then becomes incredibly easy to manage those entities as a workload versus having to manage 10s or 20 or 30 or even hundreds of LUNs on the array. So in an example here, we have a pair of adaptive arrays and a pair of all-flash arrays in a single scale-out cluster. So we can scale up, scale out, scale deep as well. So this is a single namespace, a single...
Excuse me, is that a new feature or was that already present when you went with all-flash arrays?
So Nimble's been able to scale out now since NimbleOS 2, which came out around about 2013. And it was the original design for Nimble was to be able to scale out in any direction. So to scale up, to scale out, and to scale deep. With the knowledge that we knew that we were going to be doing all-flash in the future. So that all-flash is not a knee-jerk reaction to us. It's always something that we're going to do.
But I'm speaking about this application-centric or application-aware view. Was that something that you introduced recently, or was that something which was...
This is always been in the array. So we've always had these application policies there. It's only now does it actually make sense to expose them, because now we can actually manage them across different platforms. But also with the advent of Docker, containers, and also vVols, this is where it becomes really interesting. So more on that in a second. So in this example here, I have a pair of adaptive arrays and a pair of all-flash arrays in a single namespace. And I've got different applications residing on different types of storage. The great thing is that everything can now be controlled through a RESTful API and PowerShell. I can also do all this through the VMware web client or the C client should I want to. I can also do it through Hyper-V Virtual Machine Manager. I can also build my own. But the great thing is I can actually pick up and move those workloads as an entity from one type of storage to another without application disruption. So I can essentially move that entire workload with the requirements of the data services from a secondary storage layer to a primary storage layer, if I have an all-flash array and a hybrid array, for example. This is a really good way of actually doing phased migrations of technology from a legacy array to the newer array, for example. It's part of the reason why we did scale out is because it gives us a one-click migration process to move the data services around without actually needing to pause or shut down the applications on top. So now the VMs and the applications have no idea that we're now moving around the data sets on the storage array. The storage array hides that all through virtualization layers on our scale-out cluster. And as I mentioned, it becomes really, really interesting as we're starting to move into this containerized / vVol world. The big announcement today was vSphere 6.5, and that also brings in VASA 3.0. I think that's going to really kick on the adoption rate of vVols. Today, it's been something that people are talking about, but not really much has been done so far. Now that we've got native replication and recovery of virtual machines within the vVol framework, I think we're going to see that really, really taking the market. So now what we've been able to do is we can now remove the storage constraints of a common data store. Because traditionally, with a block-based storage architecture to VMware, what that essentially means is I create a 2 terabyte all the way up to a 64 terabyte LUN, and I put a load of VMs inside it, and I get noisy neighbors. But also, if I want to snapshot, backup, and replicate it, I have to do it on the entire LUN. It's not that great for bringing things back either. So what we can now do is we can now present those application profiles natively to the VMDK. So now every single C drive, D drive, E drive that I want to create on a VM level can now get those application policies with all of the requirements that I may need for the data services. It also now allows me to put application granular controls in. So we have auto quality of service built into NimbleOS, with manual quality of service actually coming in the next release. So we can now put quality of service actually on the application requirements versus having to quaz 20 LUNs versus another 20 LUNs, which is what we do today. But also it allows me to align storage with my application policies, but more importantly, my business policies. Because now I am completely compliant from the application level and the business level all the way down through to the application, the infrastructure, and then the storage. So we now remove that requirement for that large data store, and each individual VMDK now becomes a native Nimble volume with the application profiles assigned to it. So it allows me now to get application-based provisioning. So I can now provision a VMDK based on SQL Server block sizes, on encryption with compression, and local and remote snapshot retention. I can now do application-level cloning and snapshots. So now I can snapshot native Nimble snaps and clones on the array and present them natively back up to vCenter without having to use the VMware side snapshot functionalities. So now I can use Nimble's native, really, really cool snapshot technology and cloning technology and offload that all the way from the ESX servers. The really nice thing about NimbleOS is there's no licensing. It's all just built in. So every time that we release a new piece of functionality, all of our customers get this, just part of their support contract. It also now allows me to get application level encryption. So we now do FIPS 140-2 encryption at rest on the array, and we can do that on either a per application level, or we can do it on the entire array. So customers can now run encrypted volumes alongside non-encrypted volumes on the same storage solution. So we're not having to use self-encrypting drives in order to do it. On an all-flash array, that's really important because self-encrypting SSDs are eye-wateringly expensive. But it also means now that I can get app-centric replication. So I can now retain and restore based on the application that I need versus having to manage 10 to 50 data stores, each with 2 to 64 terabytes in size. So my main man, Duncan Epping, who I'm sure everyone knows in the room, has actually been playing around with this, and I've been working with him actually on the labs with this. And he did tweet this a few months ago that he does believe that it's actually one of the best implementations. Now, the really important thing about vVols is that it puts all of the requirement back on the storage vendor. So now it's up to the storage vendor to make it good as they can about how good their implementation is going to be. If you've got a legacy system with LUNs, RAID sets, aggregates, pools, that's all you're going to be able to manage actually in a virtual volume layer. Whereas with us, because we stripped all of that back, we can now manage it on the per application, which is exactly what a virtualization admin is going to want to do. But there's more than just VMware. Even though we're at VMworld, the world is bigger than just VMware. So we're seeing a lot more of the OpenStack and the Mirantis kind of world coming in. So we now have full support for that infrastructure, and that's ready to go. And we have some really, really big customers using Nimble in OpenStack deployments. And then we know that Docker's there, and it is here today, and it's going to be even bigger. So we have native Docker integration with our app-centric integration to be able to provide provisioning, snapshot, clone, restore functionality natively within Docker. So we actually have a demonstration for you of the vVol integration, which I thought that you guys might like to see today. It's actually on VASA 2.0 versus VASA 3.0. Shamefully, it's not a live demo. It's a recorded one that we did over the weekend. But if you bear with me, what I'll do is I'll talk you through the demo as it plays. So this is the wonderful vSphere web client that we all know and love. And we've gone into the policies. So we've created some policies here, which you may see. So we've got operating system. We can see SQL databases, encrypted. And what we can then do is we can go into the operating system policy that we created ourselves. Now, you can edit the policy there. And then if you flip over to the compliance, or if you flip over to the monitor, you are able to then be able to see who's using that and how it's compliant. So you can see here that we have a vVol data store, which is 10 terabytes in size, which we created on the array. So it's a vVol container in VMware's world. We then have all of the VMDKs assigned to that for all the different C drives that we created with this operating system policy. So I can then check to ensure that they're compliant or not. We can then see the VMs that are actually running that, and we can see if they're powered on, powered off, and actually how they're using it. And if we were then to go into the Edit Settings button, we can then show you exactly how that works from a policy perspective. So we create the rule, and when you create the rule, essentially that will then speak natively to the VASA provider. And you can see rules based on data services, which is Nimble Storage. So we can now present those application policies natively to VMware. So it shows SQL, SharePoint, Oracle. I can create my own policy if I want. But it's
Provider is part of Nimble OS? Or?
So VASA provider lives in the controller of Nimble OS. So every time we do a Nimble OS upgrade, that will patch the VASA provider. Actually, all of VMware integration, our VMware integration plugin for the web client and the C client actually lives natively within Nimble OS as well. So it's a one-click upgrade.
Multiple array, how can you enable those multiple VASA provider?
So we have one VASA provider which handles the group. So Nimble works as a group perspective. So we don't have multiple systems, we have a group with nodes. Yeah. So.
Okay, so the availability of the VASA provider is in the controller, so you don't... instead of other solution where is a virtual machine that you can lose.
Right. So it's not a VM that's spun up, which then you have a three-way communication layer, because that is a big single point of failure. So it's one of the key decisions that we made was to put it into Nimble OS, because our systems are natively HA by design, We're running today at 5 nines and a 7 availability in the field. That's 17,000 systems. So we know that we're going to be able to make sure that that's HA natively in the box. So coming back to the demo, we can then create a policy based on, do we want to deduplicate it? Yes or no. It's an operating system, so absolutely let's deduplicate it. I can set a snapshot policy, so I want to take snapshots every hour for 30 days. A replication policy to replicate it to the DR site and keep it over there for a certain period of time. I can also select, do I want it on all flash or not? And also I can select, do I want it to be encrypted or not? So I build the policy within VMware. So once I build the policy in VMware, it becomes incredibly easy then to be able to go and provision VMDKs. So if we go back to the VMs and templates screen, we have a VM here, which is JH2 prod. The screen freezes slightly here, but we'll be able to move it on in a second. And we're actually going to go and add a new VMDK to that server so we can actually see how that works on the array. Okay, so we have the 2 hard drives that we have provisioned, a 50 gig and a 100 gig. We're going to provision another one now, and that will provision a 700 gig. The key here is to actually click the drop-down menu for the Advanced tab, and in that Advanced tab, you can then change the policy. So I can now have a policy for my C drive being operating system, my D&E drive being database encrypted and log encrypted, for example. You will notice that everything is thin provisioned. So Nimble does full thin provisioning on the array, and now that thin provisioning is passed natively, the intelligence is passed natively up to VMware. So everything will be thin provisioned by design. So now that we've created that, if we go to the array UI, if I just pause that there, you can see here, paused at the wrong place. You can see here that I have a series of volumes for my vVol. So I have a config vVol, I have a swap vVol, and then I've got 3 data drives. So I've got JH2 prod, and then I've got 1, 2, and 001. So that's my C drive, D drive, and E drive. So you can see here that we've got the new one presented at 700 gig, which is just there, but it's 0 gig and used. And if we were then to go inside it, you can see that it's the SQL Server block size. It has compression switched on. It has the performance policy of SQL. It's connected, it tells me who it's mounted to, it tells me what data store it's part of, and it tells what the protocol endpoint is and mapped to on the storage side as well. So it's a one-click provision on the storage array, exactly how the application guys and also how the business are going to mandate that that application needs to be managed, governed, and retained by. And this is just then going to go through and do the usual formatting that we expect to see within a Windows server. But the nice thing about all of this now is essentially it stops the arguments between the storage team and everyone else. Because storage guys think about LUNs and RAID sets and constructs that no one else is really familiar with within IT infrastructure. And what we're seeing actually as storage guys is we're seeing a convergence of responsibilities within the IT teams, right? So you don't have dedicated storage guys. You've typically got a guy that does storage and networking and compute. So,
question, when you're engaged with customers, are you engaging a lot with storage guys or more with, let's say, virtualization administrators?
It's becoming a blur, right? So in the olden days, yeah, it was storage guys, but now because the roles are converging, it's becoming a bigger conversation. And it's a lot more interesting, and I think this world, the Dockers of the world and the OpenStacks and also vVols, it's going to kind of, the projects are going to merge and it's going to become a lot more interesting, I think, from a discussion point of view.
I think our customers also see a trend to moving towards generalists rather than having domain specialization. Because if I have domain specialization, then I have to make sure I've got enough team to be able to scale and support and cover for holidays. So, and then I have experts in the team. We all know experts are really, really expensive. So we're seeing a lot of customers move towards a more generalist approach with not having their domain expertise.
And arguably, we're probably the enemy of the storage guy. If you think about it, because if somebody's used to managing a really complex solution, and this is so super easy to use.
I'm just asking because it seems that more and more storage arrays are, storage systems are getting more and more sophisticated, yet simpler and simpler to use. That's why I'm asking if you're talking more with storage guys or less and less and less.
Yeah, so, and that actually goes to a point that Rich said and what Demetrius said. every storage array today is easy to use, right? Everyone has a pretty GUI. But actually, easy to use is only a subset of the easy to consume model, right? How do you scale it? How do you get trained on it? What happens when it goes wrong, right? Those are the things that become really important. So what we're about is, yeah, okay, we've got a nice GUI, yeah, we've got the nice integration, but actually we want to try and solve everything else that happens around it. And so storage guys absolutely are more interested in what we can do to help fix issues, because when storage is working correctly, they get left alone. When it goes wrong, the finger gets pointed at them, and they are under massive amounts of pressure to try and fix it. So that's what we're trying to address and trying to fix.
And if I may, the higher-ups, the C-level guys, CIOs, CEOs, etc., what they care about is total uptime, not storage uptime. They don't care about the storage, they care about their application uptime. If we can fix problems with the infrastructure overall, not just the storage, are you going to talk about examples where we fix it?
Yep. Yeah.
So you'll see, we're going to talk about examples where we're fixing things way outside the storage.
How many customers do you have now running actually on vVols?
I actually looked the other day. So we have over 150 production customers on vVols at the moment. Bear in mind that there is no native VMware supported recovery of vVols today in VASA 2.0. 150 is pretty big.
Yeah.
And we can do recovery of the vVols ourselves. It's a support led process, but we can do it. There's just no ability within vCenter, there's no intelligence within vCenter to get it natively back up. That will change as part of VASA 3.
And what's the main reason people want to switch over to like the vVols mechanism?
Well, the main reasons are that we all know what the challenges are with block storage with data stores. It's a little bit cumbersome to manage, especially at scale. When I need to extend them, that's a real headache. And then it's all about using storage DRS to move things around to ensure that everything's running correctly. The vVol idea is actually taking it back to what it should be, but essentially with the vVols we can now expose all of this native goodness directly.
Granular data services, that's really the...
Yeah, okay. But it's like the bigger customers to make it easier to manage.
It's easier to manage, but also it's easier to scale, but also it's easier to troubleshoot when things go wrong. Troubleshooting block storage and data stores is not the easiest thing in the world.